Hello students, welcome back to video lecture series for the subject Mathematics 3 for all my mechanical engineering students and myself Dr. Ankit Acharya. And as you all know that in this chapter, that means roots of algebraic and transcendental equation, in last lecture we discussed about Newton-Raphson method and we solved some important example. So in Newton-Raphson method also we can derive formula for square root of n for any natural number. Okay, and in general also we can derive for kth root of n, in general cube root of n, fourth root of n, in general kth root of n. Okay, so in today's session first we discuss about how we can derive iteration formula for square root of n using Newton-Raphson method, and let's solve one example. Okay, so here you can see that using Newton-Raphson method, okay, derive the iteration formula for square root of n and hence find square root of 28, square root of 65, square root of 3, correct up to 3 decimal places. Okay, so this is my example. So we know that Newton-Raphson method, what is our formula? So first of all, because of we want to find iteration formula for square root of n, so let x is equal to square root of n. Okay, so x square minus n equal to 0, taking square on both the sides. Okay, taking square on both the sides, so x square minus n, that is equal to 0. So now this is my f of x. F of x is what? X square minus n, and f dash x is 2x. Okay, and now this is my Newton-Raphson method formula. Okay, xn plus 1, that is equal to xn minus f of xn upon f dash xn. So this is the formula for Newton-Raphson method. Okay, so this equal to xn minus f of xn. What is f of xn? Xn square minus n. Xn square minus n and upon 2xn. Okay, xn square minus n upon 2xn. Now 2xn, taking LCM, so 2xn into xn, so 2xn square, when we calculate this, so just write here 2xn square, okay, minus xn square and plus n, minus minus plus n and upon 2xn. Okay, so that's why you will get 2xn square minus xn square, so you will get xn square plus n upon 2xn. Clear? So this is the formula for square root of n for any natural number n, square root of n using Newton-Raphson method. Okay, so this is the formula xn plus 1, that is equal to xn square plus n, capital N, upon 2xn. Right? So easily we can derive formula for square root of n using Newton-Raphson method. Now let's I will solve first example, square root of 28, and try to solve another two examples like root 65 and root 3 yourself. Okay, so this is the iteration formula for square root of n. F of x is x square minus 28, f of 5. Now I want to first of all find out that root of this function is in between 5 and 6. Here you can see that f of 5 is what? F of 5 is minus 3, negative, and f of 6 is 8. Okay, so f of 5 is negative and f of 6 is positive, so definitely your root lies between 5 and 6. Okay, 5 and 6. So let's start with x0 is equal to 5. You can also start with x0 is equal to 6. You can also start with x0 is equal to 5. You can also start with average of 5 and 6, that is 5.5. Okay, so x0 is equal to 5. Now this is the formula xn plus 1, which we derive, that xn square plus n upon 2xn. So xn square plus 28, n means 28 because we find square root for 28. So xn square plus 28 upon 2xn. Okay, put all this value. So first approximation, this is my first approximation. Okay, first approximation x1. Okay, first approximation x1, that is x0 square plus 28 upon 2x0, so that is equal to 5.3. Here you can see that 5.3 x2. Okay, second approximation, this is my Second approximation, x2 that is equal to x1 square plus 28 upon 2x1. So here you will get using calci, because x1 is 5.3, so put value 5.3 here. If suppose I calculate, so this equal to, okay, suppose this can be written as, what is your x0? x0 is 5. So please calculate this term, 5 square, that is 25 plus 28 upon 2 into x0. So x0 is 5. So 2 into 5. Okay. So this is 25 plus 28. Here is 53. 53 by 10. So that's why this is 5.3. Okay. Similarly, put 5.3 here. So 5.3 whole square. 5.3 whole square plus 28, okay, upon 2 into 5.3. So that's why you will get 5.2915. If 5.2915 in next approximation when we put, so again you will get 5.2915. So that means what? Approximate root of function f of x square minus 28 is 5.2915. That means square root of 28 is 5.2915. Okay. So the moral of the story is, using Newton-Raphson method, we can also derive the iteration formula for square root of n, cube root of n, in general cube root of n, and we can solve some of the examples, okay, using Newton-Raphson method. So Newton-Raphson method is now complete, and next and last method of this chapter is secant method. Okay, secant method, right? For secant method, you have to remember this formula, first approximation x2, because first of all we know that x0 and x1, that we have to find, x0 and x1, that you have to find. That means suppose f of x0 greater than 0 and f of x1 is less than 0. So that means your root lies between x0 and x1, and vice versa. Suppose f of x0 less than 0 and f of x1 greater than 0. Okay. So your root lies between x0 and x1. Okay, x0 and x1. So x2 is equal to x1 minus x1 minus x0 upon f of x1 minus f of x0 into f of x1. This is the formula, okay, for secant method. Almost similar like regular falsy method, but in regular falsy method, in next approximation, every time we have to check that your root lies between x2 and x0 or x2 and x1, and depending upon your root lies between x0 and x2, your formula become changed. Okay, but here the formula is fixed. In any case, now xn plus 1, in general xn plus 1, that is equal to xn, okay, minus xn minus 1 upon f of xn minus f of xn minus 1 into f of xn. So this method is similar to regular falsy method. This method starts with two initial approximation, x0 and x1, and calculate x2 by the same formula as in regular falsy method. Okay, but here the formula is fixed, as I told you, that xn plus 1 is now every time, now your first root lies between x0 and x1. Okay, so x2, when you find x2, right hand side you have to use x0 and x1. Now x2 is, you will get, okay, now when you find x3, right hand side you have to use x1 and x2. For x4, right hand side you have to use x2 and x3, okay, and so on. So this method is almost okay. Now find the root of this function x log x base 10 minus 1.9, that is equal to 0. Correct up to 3 decimal places, and your root lies between, they already given that your root lies between x0 is equal to 3 and x1 is equal to 4. But sometimes x0 and x1 is not given. So in that case, you have to find out first of all x0 and x1. That means first two initial approximation that you have to find, that your root lies between x0 and x1. Okay. So here already they given that x0 is equal to 3 and x1 is equal to 4. So first of all, what is your function? Function is x log x base 10 minus 1.9. x0 is equal to 3, x1 is equal to 4. So f of 3, here you can check that f of 3, that means for that you have to check that 3 log 3 base 10, okay, don't forget here base 10 minus 1.9. So this value you will get, please all the students check all this value in your calci. So minus 0.4686 and f of 4, okay, so that means 4 log 4 base 10 minus 1.9. So you will get 0.5082. So one value is positive, one value is negative. Okay, so xn plus 1 by the second method, xn plus 1, that is xn minus, this is the formula, xn minus 1 upon f of xn minus f of xn minus 1 into f of xn. So first x2, okay, x2. So x1 minus x0 upon f of x1 minus f of x0 into f of x1. So 4 minus 3 upon f of x1. What is f of x1 is 0.5082. So just I put value 0.5082 minus minus. So that's why here plus. Okay, this is minus, and f of x0, that is also minus. So minus minus plus 0.4686 and into f of x1. What is your f of x1? F of x1 is 0.5082. Okay, so 0.5082, right? So the answer is 3.4797. Okay, please calculate all this value in your calci. F of x2. Now f of x2, that is f of 3.4797, that is equal to minus 0.0156. Okay, minus 0.0156. Okay. Now f of x2. Okay, f of x2 find, because to find x3 we need x2 and f of x2 both, x1 and f of x1 both. Okay, so when we get x2 we find f of x2. Okay, f of x2 is negative. Okay, so now x3, the next approximation x3, that is x2 minus x1 upon f of x2 minus f of x1 into f of x2. So that will get 3.4797 minus, what is your x2? x2 is here. x2 is 3.4797. Okay, so I put value here 3.4797 minus x1. What is your x1? x1 is 4. Okay, here you can see that x1 is 4. So minus 4. This is the value of f of x2. Just we find. Okay, here, and this is f of x1. Okay, f of x1 is here. You can see that f of x1. Just a minute. F of x1. This is 0.5082. Okay, 0.5082. Right. So put all these value f of x2, f of x1, x2, x1, and calculate this term. So you will get 3.4952. Okay, here you can see that 3.4797. 3.4952. The x2, the value of x2 is 3.4797. Okay, and what is your x3? You will get 3.4952. So only first decimal is same. Okay, from second decimal difference. Okay, here 7, here 9. So again we have to go further. Okay, x4. So x4 is x3 minus x2 upon f of x3 minus f of x2 into f of x3. Okay, f of x3 just we find here. Okay, f of 3.4952. Okay, so x3 is 3.4952 minus 3.4952 minus 3.4797 upon f of x3. F of x3 is minus 0.0005. Minus plus 0.0156, okay, into minus 0.0005. So the answer is 3.4957. Since x3 and x4 are same up to 3 decimal places, the root is 3.495. Okay, because x4 you will get 3.4957. Okay, so 495 up to 3 decimal places you will get same. Okay, here So they already mentioned that correct up to 3 decimal places, right? So that's why your answer is 3.495. You can say. Clear? Very easy. Let's try to solve one more example using secant method. Okay. Most probably in examination they mention the name of the method. Either you have to solve, you have to find the root using Newton-Raphson method, secant method, regular falsy method, bisection method. Okay. So whatever the method they mention, you have to use that method. Okay. Only. So find the approximate root of the equation x cube plus x square minus 3x minus 3 is equal to 0. Correct up to 5 decimal places. 5 decimal places. Okay. So after point up to 5 decimal places, your approximation must be same. Okay. So what is your f of x? F of x is x cube plus x square minus 3x minus 3. So here you can see that let's start with x0 is equal to 1 and x1 is equal to 2. So f of 1 is minus 4 and f of 2 is 3. Okay. F of 2 is 3. Okay. And xn plus 1. Xn plus 1, that is xn minus xn minus xn minus 1 f of xn upon f of xn minus f of xn minus 1 into f of xn. Now because your root lies between x0 and x1, so when we find our next approximation x2, we have to use x0 and x1. So x1 minus x0 upon f of x1 minus f of x0 into f of x1. So 2 minus 1 upon 3 plus 4 into 3. So 1.57143 x2, f of x2 you will get minus 1.36442. Please all the students calculate all this value. Now next approximation is x3. Okay. Now when we find x3, we have to use x1 and x2, and we have all these values x1, x2, f of x1 and f of x2. Okay. So x2 minus x1, f of x2 minus f of x1 and f of x2. Okay. Here. So when we calculate all this value 1.57143 minus 1.57143 minus 2 upon minus 1.36442 minus 3 into minus 1.36442. So you will get 1.70541. Immediately we have to find f of x3, because to find x4 we need f of x3. So that's why that is negative value. Now the next approximation x4 when we find all this value you will get 1.73514. Okay, f of x4. Please all the students calculate all these value. I hope you all can understand. Okay, all the calculation, all the important steps are given in this video. Okay, so x4 minus x3, and the final answer you will get here. You can see that what is your x2. X2 is just I mentioned here. Okay, what is your x2? X2 is 1.57143. 1.57143. What is your x3? X3 is 1.70541. What is your x4? X4 is 1.73514. And what is your x5? X5 is 1.732. Okay, 1.732. What is your x6? X6 here 1.73205 and x7. Okay, that is 1.73205. 1.73205. Okay, so x6 and x7 both are same up to 5 decimal places. So the final answer is 1.73205. Okay, all the calculations are available here. Okay, so you can easily understand and check all the calculation, all the values, and verify yourself. Okay, so in today's session, just we discuss about first of all Newton-Raphson method. We already discussed in previous lecture, but using Newton-Raphson method, how we can find iteration formula for square root of n, that we discussed today. And next secant method, last method of this chapter. So this chapter is complete now. The name of the chapter is numerical solution of, that means roots of algebraic and transcendental equation. Okay, and in this chapter we have total 4 methods. First one is a bisection method, Next one is regular Palsy method, then Newton-Raphson method, and Secant method. So for confidence level, you have to solve more and more example. Okay, so you can solve all the example in your examination. Okay, up to this. Thank you.